Control flow statements. Now, I promised you earlier, so in this section, we're going to learn the fundamentals of Java programming language. And we're going to learn decision-making statements, such as if statements and switch case statements. Then we're going to have fun with looping statements, such as for each, while, and do while as loop statements. Then we're going to learn the branching statements, such as break, continue, and return. Decision-making statements. Decision-making structures have one or more conditions to be evaluated or tested by the program. So if you look at the diagram, it shows if some condition occurs, check the condition. If that condition is true, execute the conditional code. If the conditional is false, pass the conditional code, and then continue. Make sense? So there are two types of decision-making statements in Java. They are if statements and switch statements. If statements are used to test the condition. So it'll check the Boolean condition, true or false. There are various types of if statements in Java. We can classify these statements as if statements, if-else statements, if-else if-ladder statements, and a nested if statement. So why don't we take a closer look at the if statement and the if-else statement syntax. First up, Java if statement tests the condition. If the condition is true, it executes the if block. And then secondly, the Java if-else statement also tests the condition. If the condition is true, it executes the if block. Otherwise, the else block is executed. So why don't I show you some examples of the if-else statement. So in the exercise project, right-click on the source folder and select New and Class. Specify the package name as Decision Making and the class name as if-else statement. Select the checkbox for the main method. So here we're going to use the scanner class for getting input from the user in Java. Now first, we'll need to import the scanner class. And if you hover your mouse over the scanner word, the word scanner there, see how the import options are shown? So if we choose import scanner class in java.util package to import the scanner class, we get a message to enter the number by using the print method. And we'll declare a variable number with the int type and assign next int as our method of scanner class to this number. So now let's start to write the if statement. In the if statement, we'll check the number, whether this number is even or odd. So if a number is divisible by 2, then it is even, otherwise it's odd. So we'll use a modulus operator to find the remainder. If the remainder is 0, then the number is even, right? Then finally, we'll close the scanner object by using the close method. Okay, so let's go ahead and run the code. In the console screen, we'll enter 8, and 8 is an even number, so the condition is true, and codes inside the body of the if are executed. Okay, so let's run the code again. And in the console screen, let's enter 7. 7, of course, as you and I both know, is an odd number, so the condition is false. And the codes inside the body of the if are not executed. So now let's add the else statement to the code. If the condition is evaluated to be false, the else statement is executed. And we'll add the print method to include number is odd text in the else block. Okay, so let's run the code. On the console screen, we'll enter 12. And we get number is even, and that's the message from the if statement. And that's good. So let's run the code again, and we'll enter 13, and we get the number is odd, and that's the message from the else statement. All right, so I hope you feel like we're getting somewhere, because we are. Let's have a closer look now at the if, else, if ladder statement, as well as the nested if statement syntax. So first, the Java if, else, if ladder statement executes one condition from multiple statements. And then secondly, the nested if statement represents the if block within another if block. So here, the inner if block condition executes only when the outer if block condition is true. All right, so let's stop talking and do up some examples with the if ladder and nested if statements. In the exercise project, right-click on the decision-making package and select New Class. Specify the class name as if ladder nested if statement and select the checkbox for the main method. Now first, we'll need to import the scanner class for getting that input from the user, right? And we'll choose Import Scanner Class in java.util package to import the scanner class. And now we get a message to enter age by using the print method. So let's declare a variable, your age, with the int type, and assign the next int method of scanner class to this variable. Now let's start to write the if statement. If your age is less than 13, then we'll print you are a child to the output. Else, if your age is less than 19, then we will print you are a teenager to the output. If your age is greater than 19, else statement is executed, and we will print you are an adult to the output. So if all test conditions are false, the code's inside the body of the else statement is executed, right? Okay, so let's run the code. On the console screen, we enter 8. 8 being less than 13. So the first if statement is executed, and the output is you are a child. Let's run the code again, and we'll enter 15. The program checks first the if statement. 15 is less than 13, so the first if statement is not executed, right? The second if statement is checked. 15 is less than 19, so yes, this condition is true, and the statement is executed. So the output is, you are a teenager. So let's run the code again, and let's enter 45. The program checks the first if statement. 45 is greater than 13, so that condition is false. Then it checks the second if statement. 45 is greater than 19, so the condition is false. Then the else statement is executed, so the output is you are an adult. Now let's add a nested if statement into the else statement. If your age is less than 65, then we will print "you are an adult" to output. And then when we add the else statement, that means that if your age is greater than 65, we will print out "you are a senior" to the output. Okay, so now let's run the code. And in the console screen, we'll enter 56. Else statement is executed because 56 is greater than 13 and 19. And the else statement, 56 is less than 65, so the if statement is executed, and the output is "you are an adult." All right, so let's run the code again. Let's enter 68. In the else statement, 68 is greater than 65, so the else statement is executed, and the output is "you are a senior." See how that works? So now let's write a Java program to find the largest of three numbers and implement a nested if statement. We'll use the scanner class for getting input from the user, and we'll show a message to enter three numbers by using the print method. So let's declare four variables that their names include number 1, number 2, number 3, and largest number with the int type, and assign the next int methods of the scanner class onto these variables. So now let's start to write the if statement. If number 1 is greater than or equal to number 2, this is outer if. So if we add the nested if statement, if number 1 is greater than or equal to number 3, then assign number 1 to the largest number, else assign number 3 to the largest number. Okay, so let's continue with the outer else statement. So we add nested if statement again. If number 2 is greater than or equal to number 3, then assign number 2 to the largest number. Else assign number 3 to the largest number. All right, so let's print the largest number to the output by using our print method. And then finally, we'll have to close up the scanner object by using the close method. Okay, so let's run the code. Now, on the console screen, we'll enter 6, 5, and 12. So our program checks the outer if block first. 6 is greater than 5. The condition is true, so the outer if block is executed. And then in the outer if, the program checks the inner if 6 is less than 12. The condition is false, so the inner if is not executed, and the else statement is executed. You with me? And then 12 is printed out as the largest number. All right, so let's run the code and enter different numbers, such as -2, 1, 0. Largest number is obviously 1. So sure enough, in this lecture, I think you can play them back again, but I think that we did enough examples to understand the if statements. But to get used to it, to make it repetitive, to make it a habit, you should do some more exercises. Now, in this section, we're going to learn how to use the switch case statement and understand how to control the flow of our program's execution. Switch case statement. It'll execute one statement from multiple conditions. So it's like an if-else, if-ladder statement that you learned in the previous lecture. But the switch case statement works with primitive data types such as byte, short, int, and long. Remember those? So it also works with strings as well as enum types that we're going to get to in the following lectures. So have a look at this diagram. The switch case statement starts with a switch keyword and a conditional expression between brackets. So if case condition 1 is true, code block 1 is executed. If case condition 1 is false and case condition 2 is true, code block 2 is executed, right? So if case condition 1 is false and case condition 2 is false, if case condition N is true, then code block N is executed, right? So if all case conditions are false, the default code is executed. Now, there are a few important points to remember when we use the switch statement. There can be one or n number of case values for a switch expression, if you remember your simple algebra. Now, the case value must be of a switch expression type only. All right, the case value must be literal or constant. We cannot use variables. So also, one of the new features added in Java 7 is the capability to switch on a string. So the case values must be unique. Otherwise, a compile time error will happen. Each case statement can have a break statement. Break statement is not mandatory. It's optional. Also, when control reaches out to the break statement, it jumps the control after the switch expression. So if a break statement is not found, it executes the next case. So how about a nice juicy example? Let's make the days of the week with a switch case statement. So go into the exercise project, right-click on Decision Making, Package, and select New Class. Specify class name as switch case statement. And select the checkbox for the main method. And then before coding, let's move the console panel to the right side of the screen to view the code examples, better. Okay, so that looks good. Why don't we get started? So first off, we're going to need to import the scanner class for getting input from the user. And we'll choose Import Scanner Class in java.util package to import the scanner class. Now, we do get a message to enter a day number of the week by using the print method. And we'll declare a variable day number with the int type and assign next int as our method of the scanner class to this variable. Now, let's declare a variable day with a string type. So now we can start to write a switch case statement. A conditional switch expression is day number. So in the first case, we'll assign Monday to variable day and use the break keyword. All right, so let's copy the code and make some changes for case values and other days of the week. Now, we can also use the break keyword in each case condition because we don't want to execute each case condition, right? So we have 7 days in a week. So if the user enters a number that is greater than 7, we should warn the user by using this default keyword. So in the default part, we'll assign invalid day choice to the variable day. And let's display the value of day by using the print method. Also, remember to close the scanner object by using the close method. Okay, so let's run the code, and we'll enter 3 for day number of the week. Case condition 3 is executed, and day is Wednesday is the message that we have displayed. So let's run the code again and enter 5. Case condition 5 is executed, and day is Friday is the message that we have displayed. Okie doke. Finally, let's run the code and enter 8. And the default part of the switch statement is executed, and invalid day choice is the message we have displayed. So we're going to do a lot more examples in the next exercises by using the switch case statement, but I just wanted you to make sure that you were comfortable with it. So sure enough, we're at the point where we're going to do our first project. Are you ready? It's a simple calculator, but it is built on everything we learned and also gives you an idea of some of the power of this language. So a calculator is pretty much one of the first things a programmer will learn how to build in their introduction to coding. Our calculator will be just doing some basic arithmetic operations, addition, subtraction, division, multiplication, as well as modulus. So first, let's create a new Java project and specify the project name, and we'll call it calculator. Now, don't change the other options, just click the next button. Now in this section, just uncheck create module info.java file, and then press the finish button. So in this project, just right-click on the source folder and select New Class, and then specify the package name as calculator and the class name as calculator, and then select the checkbox to add it to the main method. Now, as you may recall, or know, calculators take inputs from users, and it makes a calculation, right? So that means we need to take inputs from the user by using the scanner class. And in the first print method, we'll write a title for the program output. And let's call it calculator, all uppercase. And we get a message to enter 2 numbers using the print method. So we'll declare 2 variables, number 1, number 2, with the int type, and assign next int as our method of scanner class to these variables. Okay, so we show a message to be chosen in an operation. Now, the user may enter one of the plus, minus, asterisk, forward slash, and percent mark symbols. So also, we need to declare a char type operator, which will signify the operation that we want the calculator to perform. And assign the first element in char at method of the next method of the scanner class to this variable. The chart at method is used for taking a character input in Java. And we need to declare a variable result with the double type. Its initial value is 0.0. Okay, so if you're with me so far, let's start to write our switch case statement. Now, this switch receives the operator variable and, depending upon what it is, chooses a certain case. The first case value is additive operator in a single quotation mark. So we'll do the addition of two numbers. We'll assign number 1 plus number 2 to the variable result, and we'll want to use the break keyword. So let's copy the code and make the changes for the case values and other arithmetic operations, right? And now we'll use the subtraction operator, multiplication operator, division operator, and modulus operator. So we have 5 operators. Now, if the user enters anything except these 5 operators, we should warn the user in the default code block. So in the default part, we'll display invalid choice operator as our message to the user by using the print method. So now let's display number 1, operator number 2, and the value of the result by using the print method. Now, it's better to close the scanner object by using the close method. Okay, so let's run the code. So we'll enter 12 and 13 for our two numbers, and then we'll choose the additive operator. Result is 12 plus 13 equals 25.0. Dun, da, da, da. Okay, so let's run the code again. We'll enter 12 and 7. And let's choose the subtraction operator. Result is 12 minus 7 equals 5.0. Okay, let's run the code again. We'll enter 13 and 3. And let's choose the multiplication operator. The result is 13 multiplied by 3 equals 39.0. So far, so good. So let's run the code again. And we enter 15 and 5. So now let's choose the division operator, resulting in 15 divided by 5 equals 3.0. Alrighty then, so let's run the code, and we'll enter 8 and 5. So now let's choose the modulus operator, resulting in 8% of 5 equals 3.0. Okay, and finally, let's run the code, and we'll enter, 12 and 4. And we'll choose the illegal operator. Result is invalid operator choice. So this message is true. But also we get 12 illegal operator 4 equals 0. So this is actually a wrong message to the user. The user shouldn't see this statement. So in order to solve this problem, instead of using a break keyword, we'll use the return keyword in the default code block. You got it? So the return keyword is used to exit the current method. The break keyword is used to exit a switch statement. All right? Return keyword, exit the current method. Break, exit a switch statement. Cool. So we're going to use the return keyword in the next few exercises. So let's go ahead and run the code again, and we'll enter 12 and 4 and choose an illegal operator. And sure enough, we get only the invalid operator choice message. Good job. We finished our first project quite successfully. So let's move on. For loop. So when you need to execute a block of code a whole bunch of times, we use looping statements. So first off, we're going to learn how to use the for loop in Java. The for loop is a control flow statement that iterates a part of the program multiple times. So the general form of the for statement can be expressed like you see here in the slide. Initialization declares the initial value of the controlling variable. The controlling variable can be defined in line with the for loop or defined previously. Typically, the for loop uses an integer variable. The condition is a Boolean expression. So in other words, it must result in either a true or false output. If the condition is true, the loop continues to execute. Relational operators are what's used in the Boolean expression. So after each execution of the statements, the control variable is updated according to increment or decrement. Also, you'll see here on the slide the for loop execution flow. The first step, in for loop, the initialization part only executes once. The second step, condition in the for loop, is evaluated on each iteration. So if the condition is true, then the loop body gets executed. If the condition returns false, statements in the loop body do not execute, and the control gets transferred to the next statement in the program after the for loop. Third step, after each execution of the for loop's body, the increment-decrement part of the for loop updates the value of the controlling variable. And then the last step. After the third step, the control jumps to the second step and the condition is reevaluated. You'll see why in a minute. So let's do up some examples with the for loop. So in the exercise project, right-click on the source folder and select New and Class. Specify the package name as Loop and the class name as For Loop, and then select the checkbox for the main method. So let's start to write a program that prints int numbers from 1 to 10 by using the for loop. So we'll declare a variable I. We initialize this variable in for loop. Our condition is I less than or equal to 10, and it increments by 1. And we can use the print method to write our numbers to our screen. All right, so let's run the code. And you see the numbers from 1 to 10. So here, the variable I is declared and initialized to 1. Then the test condition is evaluated, and if this condition is true, the body of the for loop is executed and prints 1 on the screen. Then the update expression, I++, is executed. Now the value of I is increased to 2. And again, the test condition is evaluated. 2 is less than 10, so the condition is true, and the body of the for loop is executed and then prints 2 on the screen. You with me? The iteration process runs until I is 11. When I is 11, since 11 is greater than 10, the test condition is false and the for loop terminates. So now let's write a program to find the sum of the numbers from 1 to 5. We'll declare a variable sum with the initial value 0. So in the for loop, we can use variable k, and we'll declare an initialized variable k with the 0 value. So our test condition is k is less than or equal to 5, and it increments by 1. And then we assign the sum plus k to the variable sum with the add and assignment operator. So the value of k is increased until k is greater than 5. All right, so let's print the value of k in the for loop by using our print method. And then finally, we'll use the print method after for loop to display the sum of numbers. Okay, so let's run the code. And you see the values of key and sum of numbers is 15. All right then, so let's write a program to find the sum of even numbers from 1 to 10. So just go back and copy the previous code, and now make changes for the test condition and the increment-decrement part. Test condition is 10, and k increments by 2. So the variable k is always an even number. And then finally, we'll use the print method after the for loop to display the sum of the even numbers. Okay, so let's run the code. Now, you see the values of the key and the sum of even numbers, which is 30. For each loop. So in Java, the for each loop is another form of a for loop to work with arrays and collections. So we can say that it is an enhanced form of the for loop. You'll see what I mean. The use of the enhanced for loop is easier to write, and it makes your code more readable. So if you look at the syntax here, first we declare an array with initial values, and then we use the for each loop. So instead of an array, we can also use lists. In for parentheses, the first element is a single item from the array, and the second item is the list of an array. Colon is used between them. Please note here that if you do want to use the index of the element inside the loop, you have to use the for loop, and you cannot use the for each loops. So in our example, it'll iterate through each element in the numbers variable, storing it in the number variable and executing the loop body. So let's have a look and see how that works. We'll do up a few examples with the for each loop. In the exercise project, right-click on the loop package and select New Class, and specify the class name as for each loop, and select the checkbox for the main method. Now first, we'll do an example to iterate through elements of an array using the standard for loop. So let's declare a char array. Its name will be letters, and its initial value let's call it H, E, L, L, and O. Now, let's start to write the for loop. In for loop, we can use the variable I, and we'll declare and initialize variable I with the value of 0. And our test condition is I less than length of array letters, and we'll increase the value of I by 1. So let's print the elements of the array by using the index in the print method. All right, so let's run the code. And you see there the elements of the array in the console. Now, we can perform the same example using a for each loop. So let's copy the declaration part of the array from the previous code, and we'll start to write the for each loop. So in for parentheses, we declare a variable item with char type, and we'll add a colon as well as the letters array. Now let's add the variable item into the print method. Okay, so now we can run the code, and you'll see there the elements of the letters in the array in the console. So you can see the difference between the loops, right? In the for each loop, the code has reduced significantly. Also, we don't use the index and counter in the for each loop. So now let's expand in our example. Let's take a closer look at how the for each loop works. The for each loop iterates through each item in a given letters array, and it stores each item in the variable item and then executes the body of the loop. So let's do another example by using the for each loop. We'll write a program to calculate the sum of all elements of an integer array. Let's declare an integer array and call it numbers with initial values 6, 4, 3, and 5. And then we'll declare a variable sum. Initial value is 0. In for parentheses, we declare a variable num with int type, and we add a colon and numbers array. Now we assign a sum plus num to the variable sum with add and assignment operator. So let's print the value of the num in the for loop by using the print method. And then finally, we'll use the print method after the for loop to display the sum of the numbers. All right, so let's run the code. And you see the values of the num, and sum of the numbers is 18. While loop. So in the while loop, the controlling variable is defined previously. Condition is evaluated first, and if it returns true, then the statements in the loop body are executed. So generally, a loop body contains an update value for the variable being processed for the next iteration. If the condition returns false, the control comes out of the loop and jumps to the next statement after the while loop. So let's do some examples with the while loop. Go back to the exercise project, right-click on the loop package, and select New, class, specify the class name as while loop, and select the checkbox for the main method. Now let's declare a variable, I, with the initial value of 5. So our loop condition is I is greater than 1. So we'll use the print method to display numbers. Now we need to update the variable I. So we'll decrease the value of I by 1. Okay, let's run the code. You see the numbers 5, 4, 3, and 2. So after 4 iterations, I will be 1. Then our condition I is greater than 1 is evaluated to be false, and the while loop terminates, right? Okay, so let's write a program to calculate the factorial of the first 5 numbers. So let's declare 2 variables. First, k, with the initial value of 1, and the second one is fact, with the initial value of 1. And let's start a while loop with the condition k is less than or is equal to 5. And in the loop, we'll assign fact multiply k to the variable fact with multiply and assignment operator. So now we can print the value of k and the fact variable by using the print method. We increase the value of k by 1. Okay, so let's run the code. The factorial of 1 is 1. Factorial of 2 is 2. The factorial of 3 is 6. Factorial of 4 is 24. The factorial of 5 is 120. Okay, so let's write infinite while loop examples. So an infinite loop just means a loop that never ends. So if we start a while loop with the condition true, this is an infinite while loop. For instance, we declare a variable d with the initial value of 100. If we start the while loop with the condition d equals 100, this is an infinite while loop. The do-while loop. The do-while loop is similar to the while loop, with the only difference being that it checks for the condition after executing the statements in the loop body. So there's no checking any condition the first time. After the execution of the statements in the loop body and update of the variable value, the condition is checked to be true or false. So if it is evaluated to be true, the next iteration of the loop starts. If the condition returns false, the loop terminates and then jumps to the next statement after the do-while loop. So the statements in the loop body are executed at least once before the condition controlling. And that is an important point. So do you want to see what I mean? Let's do up some examples with the do-while loop. So in the exercise project, just right-click on the loop package and select New, Class, and specify the class name as do-while loop, and select the checkbox for the main method. So let's write up a program that prints int numbers from 1 to 15. First, we'll declare a variable number with the initial value set to 1. Now, let's start the do-while loop with do as our keyword. Now, in loop, we'll use the print method to display numbers. So we'll need to update the variable I. In order to do that, we increase the value of the number by 1. And now we add the loop condition with the while keyword. Our condition is number is less than or equal to 15. So let's run that code. Now you see the numbers from 1 to 15 on the screen. So in the do-while loop, the print process and increment part of the body are executed at least once before the condition. So let's write a program that chooses a fruit from a menu. So we'll need to take the inputs from the user by using a scanner class. Now we'll choose import scanner class in java.util package to import the scanner class. Now let's declare a variable choice with no initial value. And let's start to write the do-while loop. So in a loop, in the first print method, we'll write a title for the program output. Let's call it menu with all uppercase letters. And let's copy the print method and change the code. So the first option of the menu is apple. Second is banana. Third is orange. And the last option is exit. So in the last print method, we give the select and option message to the user. And we'll assign the next int method of the scanner class to variable choice. And now we can use the switch case statement for this part. And it's useful for menu operations like this one. Conditional switch expression is a variable choice. Now, in the first case, we display apple in the print method. And then we can add the break keyword. Now let's copy the code and make the changes for case values and other fruits, banana and orange in our case. So this loop is executed until the choice is not equal to 4. If the user enters 4 from the menu, the loop is terminated. So we add a while keyword with a choice not equal to 4 as a condition. So let's run the code. And then you see the menu in the console, right? So let's enter 1, and there's an apple. Enter 2, banana is displayed. Enter 3, and orange is displayed. Enter 4, no answer because the loop is terminated, right? Branching statements. Branching statements are used to change the normal flow of execution in some conditions. So Java provides 3 branching statements: break, continue, and return. Break, we've used it before. It's used to terminate loops or switch statements. control of the program moves to the next statement following the loop. Continue is used to continue the loop. When the continue statement is executed, control of the program jumps to the end of the loop, and the loop condition is evaluated. So that leaves us with return, and that's used to exit from the current method, and the control flow returns to where the method was invoked. All right, so let's do some examples with branching statements. We're going to start with a break statement. So in the exercise project, just right-click on the source folder and select New Class. Specify the package name as branching and the class name as break statement, and select the checkbox for the main method. Okay, so first, we'll use a break statement in a switch case statement. Let's declare a variable a with the initial value set to 0. Conditional switch expression is variable a. We have two case values. First one is 0. And if the value of the variable is 0, then we will print high to console, and we'll add the break statement. So let's copy the code and change the case value. And if the value is 1, then we will print hello to console, and we'll use the break statement again. So let's run the code, and you see hi as a message in the console. So let's change the value of the variable with a 1, and let's run the code. Now you see hello as the message in the console. So let's change the value of the variable with a 0. Now, if we don't use a break keyword in the first case, what will happen? So let's remove the break keyword from the code. And now let's run the code. You see the hi message and the hello message in the console. So all the cases will be executed until it sees the break keyword. That's why it's recommended to put a break after each case. So now let's use the break statement in the standard for loop. So in the for loop, we declare a variable of I with the initial value 0. Our condition is I is less than 10, and it increments by 1. So if I equals 7, we'll use a break statement to terminate the loop. And we'll use the print method to write the numbers to the screen. So now let's run the code. And you see the numbers from 0 to 6. So in this code, when the value of the variable I becomes 7, if the condition is evaluated to be true, then the break statement terminates the loop. Okay, so let's now use the break statement anywhere. Let's see what happens. So let's declare the variable number with an initial value being 100. So if the number equals 100, we will try to use the break statement. But look at that, we get an error because break cannot be used outside of a loop or a switch. Remember that. Okay, great. So let's do some examples with the continue statement. So back in the exercise project, just right-click on the branching package and select New Class. Specify the class name as continue statement, and select the checkbox for main method. So let's use the continue statement in the standard for loop. Now in for loop, we declare a variable I with an initial value 0. Our condition is I is less than 10, and it increments by 1. So if I modulus operator 2 is equal to 0, that means that if I is an even number, we'll use the continue statement to continue the loop. So we'll use the print method to write the numbers to the screen. And let's run the code. And you see the odd numbers in the console. So in this code, if the number is divisible by 2, then it's even. And if it's an even number, then the continue statement is executed. So for this iteration, the execution of the print statement is skipped, and control of the program jumps to the end of the loop. The iteration process runs until I is 10, and then when I is 10, the test condition is false, and the for loop terminates. Okay, so let's try to use the continue statement in anywhere. Now, let's declare a variable k with the initial value 50. So if k equals 50, we'll try to use the continue statement. But we get an error. Why? Because continue cannot be used outside of a loop. Okay, are you ready for some examples with the return statement? Alrighty then, in the exercise project, right-click on the branching package and select New Class, and specify the class name as return statement, and select the checkbox for the main method. So first we use a return statement in the switch case statement. And we'll declare a variable k with the initial value 1. The conditional switch expression is variable k. So we have two case values. First is 1. And if the value of the variable is 1, then we will print 1 to the console. And then we add the break statement. So now let's copy the code and then change the case value. And if the value is 2, then we will print 2 to the console. And then we can add the return statement. And then finally, we'll add the print method after the switch loop to test the statement. So let's run the code. And both of the print methods are executed and the messages are displayed. Now, because break is used to exit a switch statement, the second print method is executed, right? So let's change the value of variable k with 2, and let's run the code. So now only the first method in the second case is executed, and this message is displayed. Because the return statement is used to exit the current method. So the second print method is not executed. Okay, so let's try to use the return statement in anywhere. Let's declare a variable bool with Boolean type. So its initial value is true. And in the print method, we'll write in before the return. So if bool means that the condition is true, then we add the return statement. And then we can add the second print method that includes this statement will not be executed. Let's run the code. Only the first method is executed and the message is displayed. because the compiler ignores every statement after the return in the same method. All right. So yes, we are doing our second project. Now in this project, we will learn a mathematical concept. It's called the Fibonacci series, and we will learn how to implement it in Java. So first, let's create a new Java project and specify the project name as Fibonacci series. Now don't change the other options, just click the Next button. So in this section, uncheck Create Module Info.java file, and then press the Finish button. So in this project, just right-click on the source folder and select the New and Class. Specify the package name as Fibonacci and class name as Fibonacci. And then select the checkbox to add to the main method. Now before coding, let's remember the Fibonacci sequence, review it, or learn it for the first time, depending upon where you're at. The Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and it goes and goes and goes and goes. The next number is found by adding up the two numbers before it, right? For example, the next number in the sequence above is 34 plus 55, and that equals 89. I know, you're way ahead of me. I just had to go over it. So let's start to code. First, we'll need to import the scanner class for getting the input from the user. And then we choose the import scanner class in java.util package to import the scanner class. And now we're looking at a message to enter the max sequence number by using the print method. And then we can declare a variable number with the int type, and then assign the nextInt method of the scanner class to this variable. So let's go ahead and declare three variables with int type. First up, fib previous with initial value as 0. Second up, Fibonacci with initial value set to 1. And last, sum with the initial value 0. Now the variable fib previous represents the first number of the Fibonacci series, and variable Fibonacci represents the second number of the Fibonacci series. Now we can start to write the for loop. So in the for loop, we declare variable I and initialize it. So its initial value is 1. Our test condition is I less than or equal to number, and it increments by 1. Then we use the print method to display the numbers of the Fibonacci series. So we use the variable fib previous for this. So on each iteration, we add first the number fib previous and then the second number Fibonacci and assign this sum to a variable sum. And then we just assign the second number Fibonacci to the first number fib previous. And we assign the sum of the last two numbers to the second number Fibonacci. Okay, so let's run the code. And let's enter 10 for max sequence. And you'll see the first 10 numbers of the Fibonacci series in the console. So now let's debug the code. Debugging allows us to run a program interactively while watching the source code and the variables during the execution. So let's put a breakpoint ahead of the print method line in the for loop. Now, in order to define a breakpoint in our source code, right-click on the left margin and select Toggle Breakpoint. So we can also double-click on this position for the same operation. It's up to you. Now, in order to debug our application, we can use the Debug button in the Eclipse toolbar. So let's go ahead and click that Debug button. And let's enter 10 for max sequence. So Eclipse asks us if we want to switch to the debug perspective. So let's click Switch in the dialog window. And see how Eclipse provides debug buttons for controlling the execution of the program? So we have some shortcut keys to step up our code, and let's check the values of the variables in the debug perspective. So we click the Step Over button and display the values of the variables in the variable section. Now, at first, the fib previous is 0, Fibonacci is 1, and the sum is 0. So why don't we click the Step Over button again? No change. Let's click the button again. Variable sum is 1. So we'll click the button again. Variable fib previous is 1. And click the button now 4 times. Variable sum is 2. So let's click the button again. The variable Fibonacci is 2. Let's click the button 3 times. Sum is 3. And click the button again. Variable fib previous is 2. And let's click the button again. Variable Fibonacci is 3. And on it goes just like that. So let's click the Resume button to resume the execution of the program code until it reaches the next breakpoint. And let's click on this button until execution of the program finishes. And now you can see the Fibonacci series in the console. So I think you understand how to debug your code in Eclipse by doing this. It's pretty fun, huh? You can go back and do it again if you like it that much. Methods. So in this section, we will learn some of the methods in Java. First, we will learn what a method is and how to create methods in Java. Then we're going to learn declaration and calling of methods. Then we're going to play with some method types. And of course, we will learn method return types. Then we will learn method overloading. So what is method and method declaration? Method is a set of statements to perform an operation. Methods are also known as procedures or functions. The main advantage of method is code reusability. You can write a method once and use it multiple times. You don't have to rewrite the entire code every time. It's great. You can think of it as write once, reuse multiple times. You see the general form of a method declaration here. Now, a return type is a data type of the value that is returned by the method. So it can be a primitive type such as int, or a class type such as string or void. Now, of course, each method has its own name. So a method name begins with a lowercase letter and compound words. So in multi-word names, the first letter of each of the second and the following words should be capitalized. We'll discuss naming rules for methods in the upcoming lecture. A parameter is a value passed to the method. So methods can take one or more parameters. If the method has more than one parameter, then these parameters are separated by commas. If methods work with data, we must pass the data to the methods. And this is done by specifying them inside parentheses. So if the method does not take any argument, just simply leave the parentheses empty. So if any method is not declared void, then it must contain a return statement with a corresponding return value. The data type of the return value must match the method's declared return type. So in other words, you can't return an integer value from a method declared to return a Boolean. We'll cover method return types later on in the next slide, in fact. So the method body is enclosed between braces. The method body includes declaration of variables as well as other codes of methods. And then finally, in our example, we defined a method that its name is addNumber with the int as its data type. And we have x and y parameters, and our method finds the sum of x and y and saves the result in a new variable sum, and returns the value of the variable sum. So also we can directly return x plus y as a statement instead of assigning a new variable. Method calling. So a Java method is called according to its functionality, and it's called in any one of these two situations. The first one is when it completes all the statements, and then secondly, when it reaches a return statement. So in this example, we'll define a variable result with int data type. Its initial value is 0, and we call addNumber as our method with arguments of 10 and 20. Now, argument values are passed to the parameter. Arithmetic sum, that's the operation that's performed in the addNumber method, and the return value of the addNumber method is assigned to the variable result. And then we simply show the result value, 30, on the screen. Also, we can directly use the addNumber method in the print method instead of assigning a new variable, and the result remains the same.